So yeah, I'm David Raznick. I'm from Stroud in the UK now. I used to live in London. Over the weekend, I'm going to be doing cleaning. So it's just been cleaned before we go away for the rest of the holidays. That's my exciting weekend. I'm going to get my daughter out of the house to the grandma so we can actually clean, which would be the first time in I can't remember how many sort of years probably. So that's my exciting. That's my exciting. And I work for Open. I keep on saying Open Knowledge Manager, but it's that Open Data Services. I've been here for this company for a lot of years, but my last job was Open Knowledge Foundation a long time ago, and I was here very early stages of Open Knowledge Foundation when it was just a few people, and then they've got a bigger development team, including Adria at that time, working on CCAN right at the start. So I used to be lead developer on CCAN a long time ago. Hopefully I made it better. I've still got some guilt about not with this, but hopefully I progressed CCAN on. And then since I've been working at Open Data Services, and we work on sort of data standards, including lots of open ownership, open contracting, like Ben said. We sort of manage different standards and tools around standards and try and make those standards get into use. So there's quite a few different ones. So I'm going to give you an example of open contracting data later to show you what Flatterer does with that. So that'd be interest of Ben, which is actually on topic, which is good. And yeah, and I'm really interested in sort of how you get difficult to use data like JSON that's quite difficult to read and get it into a structured format that most analysts want to use. So Flatterer came about really due to that. In the early days, I have got some sort of history with fictionists. I used to have lots of chats with Rufus in the early days about the data package spec and all that kind of stuff. I never really got too involved because I was mostly in CCAN stuff, but I had quite a lot of disagreement with him. I was quite skeptical about it in the early days, from what I remember, and it was there was quite a lot of to. I was there was quite in the open data world. I was sort of unhappy because everybody seemed to do data manipulation, everything in their own way. They all had their own methodologies for doing it. I just wanted people to come with a single way, but I never obviously got my way of that. And I was always very much an SQL person, and I wanted tools and pipelines to be based around SQL, mainly around Postgres. And I tried to promote that. And I almost wanted the frictionless data spec to be more like an SQL database there with schemas, and I wanted it based on some kind of open source tool like Postgres, because that's got schemas and types and all that kind of stuff. So I was trying to push that, but I wasn't really involved, so it never got that way. But now I'm really happy that frictionless data sort of exists, because it's really helped with the Flatterer tool, and to have some kind of not necessarily for human consumption, like JSON specification about what's in the data, but for machine consumption is what I didn't realize is really good to have an independent format to have the machines that can both read that data and manipulate it in a certain way. And I'll explain sort of later about why Flatterers ended up using the frictionless data spec, and it's really good because then I can use all the different tools around the frictionless data to enhance the project. So the journey that sort of got me to this point, because I've been working on lots of different sort of open data standards. All of them have got very deep nested JSON. So hopefully the screen share, I'm going to start with a presentation now. Hopefully this will work. I'm a bit scared about this not working. Can you see my screen?
Yes.
And can you see that document? Yeah. And can you see this page here?
Yes.
It's a lot. This is just a bit of JSON. So this is an example, a fully fledged sort of open contracting, this is called a record. And so this is, so if you're an analyst approaching this, you've got to work out what's in this data. There is a specification and a JSON schema specification and documentation around it, but even that is quite difficult to read and parse. So the big problem is, if you've got this is the data. As you can see, it's quite hard to not only work out what all the fields are and where they all are, but also just like read the data to get anything more from it, or work out like how common, say, how many documents there are or how many items there are. So this is like a massive, and the difficult stuff about this data is that there's very sort of nested lists in it. So if you just try and like flatten it in a very sort of naive way, to try and sort of say have a list of headings along the top, and then all the different like JSON paths as heading along the top. This is what sort of most sort of flattening tools do. Then you get this massively wide spreadsheet, which is really difficult to work with, and it doesn't deal with like the repetition of like certain one-to-many relationships very well. So at my current work, we've got a tool called Flatten Tool. And Flatten Tool is a tool that deals with this, and it does do a job. So this is Flatten Tool's documentation, and it deals with certain cases of nested JSON very well. And we've worked on this, and it's a really Flatten Tool is really good, but it's really aimed towards people unflattening JSON. It's got a JSON back to, or unflattening CSVs back to JSON data, so that it can be used in the standard. So lots of people write sort of open contracting or 360 giving data as spreadsheets to begin with, and they use Flatten Tool to unflatten the data into JSON so that they can sort of have it in the data specifications that we care about, and all the validation happens at the JSON level. But as a flattening tool, even though it's called Flatten Tool, like the output representations it's got are not, they're okay, but they sort of give you not very great heading names, and they deal with nested stuff, and they give you multiple sheets as well. So it does deal with it, but it's not, it doesn't, the output representation isn't good, and you still need, and there's lots of problems with sort of how you join between the tables that it creates. So over a little while, I've been so Flatterer is like an attempt to sort of sort out the problems of Flatten Tool, and to make it like to really hone it towards sort of data that's useful from this. So as part of the sort of journey to get there, I wrote a tool called OCDS downloads. So this is specifically for OCDS data. So this has got most OCDS data in a long list. So you can have, these are all different sort of sources of OCDS data. For OCDS is like open contracting. So it's like what governments try and produce about particular contracts that they do, and there's like an open standard to publish that data on the web. And this is these are like scraping all those different sources and then giving, and the point of this tool, OCDS downloads, is to give that data, that complicated data that I showed you before, in a way that's much easier for analysts to work with. So it's like a data pipeline and one sort of regularly. So I can choose like a random source. Let's choose Ecuador for no apparent reason. And then this gives you what happens when the data is flattened. This isn't using Flatterer. This was like my first attempt at trying to write a really good handwritten way of flattening data. So what it does is it gives that data, and it gives you like all the different key parts of the data in their own separate tables, and gives you like different output formats you may want to care about. So it even gives you like an example like Jupyter Notebook that you can sort of easily go in to work with the data straight away. And it also gives you like a PG dump if you like Postgres dumps, and it uploads stuff to BigQuery for you. So there's an already online BigQuery instance of this particular data. And there's also like a CSV dump of the data. There's an Excel one, which doesn't work for this because it's too big, but for smaller data sets, it'll give you Excel, and an SQLite file. So back in the old days, I was saying that I didn't like everybody goes in their own way, and I've just sort of accepted that everybody goes in their own way in terms of how they want to manipulate the data. So I'm trying to write, the point of this was to try and like cater for many different types of data analysts. So they were, and for each table, it gives you like a field list, and then like what the type of it, is in the database, what the OCS type is, and then docs around, and that draws the docs in from the JSON schema in order to give you more information about it. So it gives like an analyst that doesn't know anything about OCS like a really good start about how to work with the data and docs around it. So they've got an idea of like which fields are actually used within this data and all that kind of stuff. So that was my first attempt at like a good general, like a flattening algorithm to work well with this kind of JSON data. So yeah, so that's got that. So I also, since then, I work for I'm also doing stuff on Iaty, which is actually an XML standard, but there's sort of fairly good tools in Python to convert XML to JSON. So what I do is convert it to JSON first, and then do the flattening on that. And that's something that Flatterer may have. And this is another example of like an example bit of data in Iaty, which is quite difficult to read and work out what fields are there. And so we made this tool called Iaty Tables, which is very similar. It's just, but this is the whole of Iaty data in one big data set, and then for that it sort of flattens it and it gives you different output formats, and it gives you like a data set instance for it. And then if you click on like a particular field, then it gives you like what the fields are and what the documentation is from the XML and stuff like that. So that was and so that uses a very similar algorithm as well. So I sort of came up with this particular algorithm, sort of flattening JSON, and then at some point I then decided to like codify that in like a tool that like anybody could use to get similar output to this, and that's where sort of Flatterer came about. Just checking for my notes if I haven't missed out. I also I also decided, because it was like I decided to write it in Rust because it was interesting to me, and I thought that it couldn't do Python bindings because most data scientists and stuff are quite happy using Python nowadays. So I could still have the Python bindings, but the reason to use Rust was it was just a lot faster, and it was also kind of interesting to me at the time to do it. And it is like compared to Flatten tool and other tools, it's like 10 times faster to do the same sort of flattening jobs as other tools, and that's why I used it. And it can use like multiple cores to make it faster as well. So then I spent quite a lot of time sort of working on Flatterer, and this is where I came up with, sorry for the ridiculous logo, but yeah, I thought I'd have to do some kind of logo. It sort of exemplifies that what it's about, and it does do some of the exports. It does sort of CSV, XLSX, SQLite, Parquet, which is a new one which people are interested in, and also it now does, which isn't in this documentation, it does like a Postgres export as well. So you can, if you put in like a Postgres URL, you can put it straight into your, that just came just about a week ago. That isn't actually probably in the docs, but not in the, yeah, it is in the docs, but it's not in the README. So there you go, I've got to do that. So yeah, so that goes through the rationale. It's just to try and make it fast and quick, like a really good way of sort of flattening raw data. It won't like deal with like all kinds of JSON data that ever existed. There's no tool that's ever going to do that, but it does deal with the most sort of common types of data. So in terms of like the algorithm it uses, so this is like a bit of an example, and it's got like a list of objects. Then it will, like for every list of objects, it will make a new table for you. So for example, so this is probably quite small, sorry. Say for here, say for platforms, and because platforms is like a list of objects, then it will separate the platforms into a new table, and if you go down here, then it will have the main table, which is all the keys on the top level here, and then it will have a platforms table, and it creates this special link between the main table, which is games, and the one-to-many table, which is, and it says, and it makes special keys like link games, so you can know where in the one-to-many you have to link back. Sometimes the data has those keys in it, but not all data does have keys to link back to the child table. And so part of the algorithm is to generate those keys, which I haven't seen like any other sort of tools try and do that. And it's just try and make that link as good, like as easy to use as possible. So that's where I went to link fields. Yeah. So I was going to try and like give like an example of how you'd actually use it. So here's some, I was like looking around for random bits of data online to give a demo for ages ago. And one of the interesting one, which is quite easy to understand, is Nobel Prize data. So if you, this is just like a random API on the Nobel Prize website, and you could look at the data. That's the raw data, which is really quite hard to read what's going on there because it's not formatted very well. But if you look at the JSON, then you maybe have to work out yeah, what's going on there. So it has got like a list of laureates under like a year and category. I don't know what's going on with that data and who the laureates are and stuff like that. So that's the data. So if like I've got this bit of data here, and I've got, this isn't a really sort of a public tool, that I've got a web interface for that. Mostly you would use it by the command line or by a Python library to do work with. But I've also produced this front end, which is mainly for my internal use, because it's quite hard to host, because I mean, I don't want people uploading massive files, and it's like it will cost a lot to host it because like people do it, but it has got like a limit to it. But if people want to like run this themselves, they can on their computer. So if I paste in say that particular bit of JSON and you go download, hopefully live demos are fun, and it doesn't look like it's working, which is always the case with live demos. Oh no, it does. I don't know why it took so long. There you go. It shouldn't have taken that long to do. So essentially you've got this bit of data, and then it gives you a preview of the table. So it's sort of a similar output to what I showed you before. It's got the fields in the main prizes table, main prizes list, and it's got things like overall motivation in there, which I didn't know existed because it wasn't in every single JSON. So it shows you how common they are. And then you've got your laureates table, which shows you sort of all the laureates, and this gives you like an example of like the first 3 rows of what ends up in that particular in that table. And there's a main table which really isn't useful, because when you look at the data, it's just the top level hasn't got any other information apart from prizes in, so it's not that useful. So I mean, there's kind of a lot of knobs that you can sort of tweak. So if you want to say, oh, I actually just want to look at the prizes table instead, then you can redo that, and then it doesn't. Oh, but then it says that, oh, the main table, it doesn't know what to call the main table name. So then you can sort of change your main table name. So you want to call that prizes again. So that I won't necessarily go into all the different like options around how it works, and I'm still confused about why it's taking any time to do it all, but there you go. So yeah, so now it's got things like that, and there's quite a lot of other things you can do, like put a JSON schema in to give you some more like information about what field names should be, because sometimes JSON schema you can put in titles, and you can use the titles for field names instead. And you can do things like put a prefix to the table name. You can like put a path separated, because normally like if it's got like a one-to-many relationship, or if it's like an object within another object, it will put like an underscore between the fields. But sometimes like if you've got underscores in your data, you may want it to be double underscores between, so you can put like a path separator of like double underscore instead, but which doesn't really show up here because there isn't any actual sub object, so that wasn't a very good demo to do. And so that's an example of that. Yeah, that's basically like how you would use it. But most of this, obviously, you would do it on the command line or using a Python library. I'll stop there for a second. Am I going far too fast? Is everybody sort of grasping what I'm talking about? I do have a tendency to just go super fast. if everybody's okay. I can't see everybody's faces at the moment.
We have maybe,
Nick.
sorry, David, one question from Nick, if you don't mind.
Yeah, of course, yeah.
First of all, this is amazing. So congratulations. I guess I think I see the answer, but you can go down the nodes quite a lot if you needed to, right? You could start off
What do you mean?
much lower than the top of the JSON structure, it looks like.
Oh, okay, yeah. So the next demo I was going to do would be like the painful, really difficult open contracting data. So if I put that into the tool, which was the next demo, which has got like very, very many levels of nesting in, which is why it's difficult. I'm not going to have it based on, this is all wrong, actually. I should have restarted. So there you go. So this is another demo. So this has got records. I've still got the double underscore in there for some reason, but there you go, between the fields. So I should probably just not worry about the double underscore and do it again. But yeah, so it's got yeah, like underscores. Yeah, so this goes records. So the level of nesting is that the interface isn't so good. There's multiple levels. This goes down, if that's the answer to your question. This goes down, and these are all the different tables that exist, and every underscore here would be like one level of one-to-many relationship there is in the data. So yeah, so that compiled releases is a one-to-many with records, and awards is another one-to-many with compiled releases. And there's like award suppliers and items, and they all have links back up to any table that's above that in the key. So they have special keys to link to any table that's above it in the hierarchy. There's somebody that raised their hand. Sorry, I missed that.
Yes, JD, I think.
Yeah.
I think you might have covered this, but does it guess what the key is, the linking key is between two tables?
No, at the moment, these link keys are generated, so it always generates them every time. So these link things are very special that I make, because I can never trust the actual keys in any data, because they could be duplicated or not duplicated. But there are ways to, in the new version, there's a way to say if there's an ID, you can push those ID fields that are in the actual data down to the child nodes as well. So you could have a way to link on those. So there's a push down thing somewhere which you can say ID, and then you can in here, and then it can push down the actual ID fields that are in the which are actually in the data. So records has got an ID in it. This data is quite big, but then it should have like records compile release ID. So that's the record that it got from the parent table. So, but it is like a very opinionated choice to have these link fields and to make sure that they're there all the time. But otherwise, I'm not 100% certain that the keys would definitely be able to match up, because the data could be wrong. And they had like in OCS, like everything, for example, there is IDs at each level where they're supposed to be, but some people put duplicate IDs in, and therefore when you start joining them, then they will fail, because you'll get like the many-to-many join thing. So as a very opinionated thing that Flatterer does, it puts these keys in for you, so you know that they're all relationally correct, and then you can maybe get rid of them later if you don't like them and you've got keys that you really like. But for that, and it also is used for like SQLite exports and the Postgres export. They're all indexed and foreign keyed and stuff when you do those kind of exports, so that it holds the integrity and it's like useful for like stuff. Does that answer that question?
Yeah, really well. So then I want to ask a follow-up. If you're adding it, if you're running it again against an existing Postgres database, can it append and then carry on with those keys from where it was, kind of thing?
Well, there is a way to put not in this version, to put a prefix to all the link keys to make sure that, so instead of just having it like naught here, there's a way to attend a prefix, like a date of the file, to every single key in order for that to work properly. So I can go on a bit later about that, but there's a way, there's another tool I've written to make to do with data packages, a way of merging data packages together, and it's been used for, I'm using it for this, so that this can go ahead and do like it on multiple cores and then join it back together again. And in that case, I have to prefix some kind of special for each sort of core, or a special like the core 1, core 2, so that the links that are generated are going to be unique. So there is a way to, like, say, I want to append something to that in order to make sure they are unique when you're appending again. And also one thing that I'm working on now, which is a way to, for Postgres specifically only, is like a way of, like, if you're appending to all the existing tables, can we go and alter the tables to add more rows if like the new data's got more rows to it? So in a way, so that's for the future, but like a way of like having schema evolution and stuff would be really interesting. I don't know whether the data package, the Frictionless does that at the moment. I haven't actually checked, but yeah, that's something I'm interested in. More hands are raised and I can't really see who they are.
Yes, so Dan, I think Nick was first, and then Dan would go later.
Yeah, me again. So based on what you just said, could you imagine a workflow where you first convert it and then you run Frictionless to see if there are duplicate IDs that were generated or something like that? Like, could you, where would you see Frictionless coming into this process if you did want to?
Okay, so as like one of the outputs, if we go right down to the bottom, there's a zip file. If you want to save the zip file there, replace, over there. One of the outputs, say the CSV output, is a list of CSV files, which is what you've just seen, and data package.json, which links all the data, which has got the metadata about all the data. It cheats the scheme a bit because it's also got counts in there, which I don't think is in the standard, but it adds a bit more to the standard as well. So therefore, you can use this output with any Frictionless tool. There.
So just clear, you could run this to the question asked earlier by JD about the IDs, not knowing whether they're duplicated or not by the users. They probably are. Let's be honest.
Yeah.
You could run this, generate the CSV with the data package, make sure that it's unique, say that these are the IDs, and run the Frictionless and actually get errors to say that there's more than one ID. Is that?
Yeah, that's fine. I mean, the whole point of these link columns is that those will never have duplicate IDs because I'm generating them. But if like the data has got IDs in it, then yeah, you can use then Frictionless on this output to do whatever you want. You can use that's the whole point of generating the data package.json for people to use for whatever kind of data manipulation they want to do afterwards. Does that make sense?
Dan, you had a question as well.
I'm curious about how it scales. Like, how fast is it, and is it capable of sort of streaming the output so that it's not IO bound?
Right, in terms of stream, it's very fast and it's very memory efficient, as long as your data, say for this kind of data, for example, is a list of objects. It uses a streaming parser for full top level lists of objects. So therefore, it doesn't hold hardly anything in memory. It just goes through each. Doesn't need to hold all the input JSON into memory. But what it does do is it does write out. So you need a certain amount of temporary space basically in order to do the first, to put it onto disk. You need enough disk, but you don't need very much memory at the moment.
And it would be, yeah, and what I meant was it would also, aside from the space, it would be limited by write speed on the disk. So if you were passing it along to a user on the other end of the network, has to write the whole thing before you can serve it to. This isn't a criticism. I'm just kind of thinking about different places I might plug this into.
Yeah, fair enough. Yeah, I haven't got a full in-memory version of it, which I've been planning to do for like a WebAssembly version of it, was one that I was interested in, because then you could have all the. But at the moment, what it does, because the data could be of any size, then the priority was to put it on disk first rather than to hold it all into memory, because I use this on like gigabytes and gigabytes of data. So therefore it's a risk to hold that all into memory. So there isn't, the problem is because like the data is because the JSON coming in could like be changing schema as it's coming in, and you don't know what the next one's going to hold, then it's quite hard to like stream that out in a way that people find happy, because the consumer would have to know that that's going to be constantly changing. But
yeah, I didn't mean streaming like forever in real time, but just in terms of the way that you write it to the disk, I think you could just have an HTTP connection open and be streaming each row of the file you're generating to the end user instead of writing to disk with each row.
Yeah, the problem with that is then, because as you're coming, as long as if you knew the schema up front wasn't going to change from like the original schema that you gave, then that would sort of be possible. But if the scheme is then, if the CSV file is going to then be different, or depending on what the output format that you want is, then that's going to be quite tricky to give it to users, and part of it does quite a lot. So one of the outputs which uses less disk is I could go on to the next bit of the demo as part of there's like, this is how you'd use it within code. So you would use like the Flatterer, just a pip install Flatterer, like a normal library for that. And then you can, it's the same data that we just saw, the Nobel Prize data. And then when you flatten it, you can, instead of necessarily having an output, you can also pull it straight into a data frame as well. So there's like a data frame output as well. But yeah, it is difficult. That is a difficult problem because of the way that the JSON can change as it's coming in all the time. What you can do, which is kind of that, as one of the outputs, there's this thing called fields CSV. Maybe it should be actually just data package now, but I should migrate it over. So you can put in a schema sort of up front to give it, so that if you want to like remove certain fields or add or make sure that these fields are always going to be in the data, if they're not, you can supply this fields.csv file. And then, I mean, I could show you what the fields.csv file looks like. I should replace, I've probably just had the same data. There's this fields.csv file, which is all the fields in just a very simple format. It's like a CSV format of like saying table name, field type, whatever. So for the next load, you can either like delete some fields if you don't want them in your output, or you can keep them there for the next time that you run this against the data. So you means that if the next day doesn't have the fields in, then it'll make sure that they are in the output CSV. But the big problem is you still don't know if the data coming in is going to change, and you want that data in. But you can say only use as one of the output formats, you can say only use the fields that are in this fields.csv. So therefore, in that particular case, you could probably have a way to stream it out, because you've sort of specified these are the only fields that I want. So if you knew the schema up front, essentially, you could do it by a streaming mechanism. So there is a way, there is like an option, but I haven't prioritized that. Only output fields in the file, in that particular file that you supply, will come in the output, so you can be assured that there'll be a way to stream it out. But it's a difficult case to stream it out, because there'll be multiple CSV files as well for certain cases. So it hasn't been something
totally. And there's other like
go.
user experience and other problems with doing that kind of streaming.
Yeah.
So I think probably in that situation, if it really writes the file, really quickly, it probably makes more sense to set up an architecture where you can generate a link that you send to the user rather than just streaming it to them directly.
Yeah, stream it straight there. Yeah, I think that's the approach that I've gone for this particular case. Yeah.
Thanks.
So the next thing I was going to show was going to be this, which is just like how you use it. So I'm jumping around quite a lot. But yeah, you just use, it has flatten, just import Flatterer, and you say your input file, and then you say what the output directory that you care about, and you can say, oh, I want it to give a data frame output, but I also want it to give the CSV output as well. And then you can, obviously it saves that that's like a tree of the output that it gives you, and then then it gives you an example like what the data package is that it generates for that. And then you can then use pandas to read the CSV, even though the data is actually already in data frames. I don't know why I've done it like that, but yeah, you can, and then that just shows you what the files are in, like how you would use it if you're doing it in code rather than the command line tool. Yeah, and then there's also like the options. These are the different types of, these are all the options you've got. So there's quite a lot of different things that most of them are in the front end that I've just shown you. I'm not going to go through all of them. If you use like JSON lines input, then you've got a threads thing. So you can multiple posts. It makes it quite a lot faster if you can do that. And the new stuff is like Postgres, and you can choose like a Postgres schema or drop the tables that are already there in Postgres if that's what you want your output format to be. But most of the output formats are here. So in order to get those outputs now, the thing that sort of changed in the last sort of few months while working on this is to sort of have a sort of a tabular data package as like the main sort of output format for it. So some of the exports, including the Parquet ones, I basically produce a data package, a CSV one, and then the next stage is then they convert it into other formats for you. So there's another library which is a Rust one as well, but it's got Python bindings. It's called Data Package Convert, which I've been working on. And what that does is it does similar stuff. So all it does is get a data package with a CSV data package, and then converts it into these different formats for you after the fact. So yeah, as long as you've got a data package, then you can do it. And so Flatterer now, instead of like having all that code internally, for quite a lot of cases, it just makes a CSV data package and then uses this library that anybody can use to convert it to Postgres to all these cases. And it definitely uses this when it's doing its multiple thread thing. So it can do like multiple threads and make multiple, so it can be about 4 times faster to do it, and then it merges all the output data packages into one after it's finished doing it in parallel for you. And yes, that's just a library. It's not like a full-fledged sort of frictionless library. It's kind of quite specific to what Flatterer wanted, but it is still general purpose. And I'm still thinking about maybe making a Rust version of some of the other frictionless tools as well. So that's where we are. I've mostly done a demo. Oh, so I was going to do a fun demo, which is a bit of like like a meta demo. If you like open this file here, which is I also work for I do some work for Open Referral, which is a data standard about like services, like human services that people provide. And this is they generate all their data in sort of friction in using tabular data package specification. So this is their tabular data. This is what their data package.json is. So I would argue that even data package.json it's quite difficult to read to see what's going on. And it also is a deeply nested JSON itself, which is a bit, so what I will do, then hopefully then I can use this thing. Let's see, there you go. I can run it through the tool and see what that looks like. So and then we can, maybe we'll go for an XLSX output of it, just for a bit of a change. So there you go, so replace, let's see what that looks like, if you can still see my screen. So this is like without me configuring it a tool very much. So this has got now all the table names. For example, this is like the resources list, and so it gives you the resources list of all the different, and it's got another field which has got all the schema fields. So it's got the name of all the fields, and this isn't actually that great an output because it does link to the main table here, or links to the resources table here, but it doesn't give you the name of the resources table because it isn't in the sub table. So maybe I should, if I'm going to do this, then there is like an option to say, I'll push down sort of name here, which is like a field that you would want. And if I do that again and download the XLSX file, let's see if this works. Replace. This isn't a great demo because I've got this team, and I don't think that's happy because it Has that worked? I think it's because it's the same name. Oh, sorry about this. This is not a good demo. It's the thing about doing demos in. I'll download the XFX file again and see if it's happy. I'll replace it and then let's load it again. And so hopefully, yes, now it's got like the resources name here. So you can, so this would be like a decent representation of like all the different like fields within the actual data package itself, which is a bit of a silly thing to use for. But this is sort of a slightly nicer format. The argument is a slightly nicer format to read than the actual sort of data package specification itself. And I have used it for like open referral to say, oh, I want all the fields in a nice spreadsheet for me to just have a look through. And this is what I did in order to do that. And then I've got a spreadsheet and then I can like see all the different fields and where they all are and stuff. Any other questions at this point? I think that's mostly, I've gone through the presentation pretty quickly. Is there any other points to make? I'll just see if I've got anything else to go on. I've gone on talking about data package convert, about merging. I've gone through all that, and a bit about like the future of where I'm going to be going with this. I am probably going to make maybe that UI, maybe give it to people a bit more because it's quite a useful tool. I talked about like Postgres scheme revolution, like maybe a way of like, if you keep on inserting into the database again and again from JSON you're getting from a source, then you can make the tables grow and change with the data that you're getting. The type detection of JSON could be a bit better. I'm constantly thinking about whether I want to write like a data package describe again for like a Rust one that does exactly what I need or something like that. And maybe more stuff to do with the data package as well. I realized I've gone on for ages, so I wasn't that quick. So if anyone's got any more questions, then that would be, that's great.
Thanks, David. I see, Dan, that you have a question.
Just a quick one.
Yeah.
I was just looking for the list of output formats for my notes.
For your notes. So it should be in the documentation is the main ones. The only real
I'll
one.
find it if it's there. That's fine.
It's like it's CSV, XLSS,
There it
SQLite,
is.
RK,
Okay,
and Postgres
thanks.
is the main lot. But in the option reference, there's a section on like the main output formats here. If you want any other, the other one that could be is Avro, which I've been playing around with the option of maybe doing Avro because that's quite good for like if you want to put it into BigQuery. But Parquet is accepted in BigQuery quite well as well.